Welcome for Arithmetic TV. Today's session we are going to start about the business statistics, and topic 1 we are going to deal with a measure of central tendency. In a measure of central tendency we have mean, we have median, we have mode. So when it comes for this, it's require you to understand more clearly. So let us proceed by mean. When it comes for mean, we have different types of mean. We have harmonic mean, we have a direct mean, we have so we have a different mean. So we are going to look into a detail. So let us start by arithmetic mean. So arithmetic mean or arithmetic average is defined as the sum of value in the data group divided by the number of value. So here what they want to mean, you have collected data from the groups, so you have to make a total of that data, and also you divide the number of data observation. Ahanga ikintu ukora ufata igiteranyo cy'izo data zose wakusanyije hanyuma ukagabanya umubare w'ibyo bintu. In statistics, a descriptive measure of population or a population parameter is typically represented by a Greek letter. Do you understand? A population will be represented by a Greek letter, whereas a descriptive measure of a sample or a sample statistic is represented by a Roman letter. You will get understanding, you will get the meaning. So here, that's the arithmetic mean for a population of the value is represented by a symbol mu. You can read a mu, while arithmetic mean for a sample of value is represented by a symbol x bar. You can read x bar. That is what we call a value of the sample. The formulas for the population mean and the sample means look like this. If you are using a sample to calculate the mean, here you take the summation of that population of that samples and also divide by n. N is the number of observation. And also you can calculate the mean by using a mu. Here you are calculating the mean by using a population. Here you take the summation of that data you have collected and also divide by n. N, which is a calculator, it is a symbol that is used for population. Operationally, the two formulas are identical. I can say are the same. In both cases, one sum of all the value and they divide by the number of the value. You have to make the sum of that values and also you divide by the numbers of that values. However, the distinction in the denominator is that in statistical analysis, the uppercase N typically indicates the number of items in a population. That's what we have looked at in that formula. While the lowercase is n indicates the number of items in the sample. Do you understand, my dear friend? Let us look for this example. During a particular summer month, the 8 salespeople in the heating and air conditioning firm saw the following number of central air conditioning units. The first was 8, second 11, 5, 14, 8, 11, 16 and 11. Considering this mass as a statistical population of interest, the mean number of units sold. This will be look like this. Because this number 8, 11, this is a sample. So to calculate the mean by using sample, you have to take the summation of that numbers of air condition have sold and also divide by number of observation. The total, you are going to take 8 plus 11 plus 5 plus 14 plus 8 plus 11 plus 16 plus 11, and also divide by the number of observation. You have to count from starting for 8 up to 11. It is in the 8, and also you get the mean from the sample, which is equal to 10.5. Do you understand, my dear friend? It is simple here. Let's go for weighted mean. The weighted mean, or a weighted average, is an arithmetic mean in which each value is weighted according to its importance in the overall group. The formula for population and the sample weighted mean are identical. That is a formula. For weighted mean, you take summation of weighted times the data collected and also divide by the summation of weighted. Let us look for an example. In my product company, the profit margin for the farm company, for the company's 4 product line during the past fiscal year, well, line A 4.2%, line B 5.5%, line C was 7.4%, and line D was 10.1%. The unweighted mean profit will be looking like this. It will be a summation of that, the mean only. It will be summation of that profit margin, and also divided by n, which we are going to take 4.2% plus 5.5% plus 7.4% plus 10.1%, which is equal to 27.4, and divided by 4, which is equal to 6.8%. However, unless the 4 products are equal in the sales, this is an unweighted average is incorrect. Assuming the sales total are in the table below, the weighted mean collected described the overall average. Here they give the profit margin and sales, and also you are going to look, the sales was totally different, so which is called weighted, and also we have product line which is A, B, C, D. We have profit margin 4.2, 5.5, 7.4, 10.1. We have sales 30 million, 20 million, 5 million, 3 million. So to make summation of sales, it is equal to 58. To get a profit, to get a weighted times x, it's we take profit margin times sales, and also get summation, and also get it weighted, which is equal 5.2%. I hope everyone is understanding this. Mean. In more general cases, those weights are often called frequencies, and the formula is look like this. You take summation of frequency times I divided by n. Let's go for assumed mean method. For the mean, the used formula is named direct mean. However, there is another method called assumed mean. This method is used to make the calculation simple. Let A be any assumed mean or any assumed number. D, I will be a deviations from the assumed mean A. Then we have a formula which is look like this. We will continue by using the previous example, where the assumed mean will be A, which is called 11. The formula is will be look like this. For assumed mean, the formula, you take A assumed number plus summation of fi di, which is called deviation, divided by n, number of observation. This is the table which is look like this. Here you have xi. In the previous example it was look like this. We have the frequency means 5 comes for 1, 8 comes in 2 times, 11 comes 3 times, and also to look like this. So you are going to take this xi minus assumed number. That means for here to get minus 6, they take 5 minus 11 and also get minus 6 and continue like that. To get a frequency, you have to get frequency times xi minus assumed number. That is what you get. So to get this, it is so simple. This is fi times xi minus a. It is a summation of ai times deviation. So that's to get assumed mean, which is equal to 10.5. Harmonic mean. The harmonic mean of the series of value is a reciprocal of arithmetic mean of reciprocals. Thus, if xi, x2, xn, none of these belong to 0, is a series and h is a harmonic mean. Hano bashatse kuvuga ngo ni inverse ya arithmetic mean uba wabonye. Bivuze ngo hano ushaka wavuga ngo harmonic mean ingana n'igiteranyo cya za frequencies ugabanyije inverse ya assumed ya arithmetic mean ugakobaho ya frequency inshuro yibara. No urugero hano dufite the marks, dufite the number of students. Here this number of students is a frequency. The marks is it will be the fi. So we are going to take this frequency, we divide by the summation of this frequency, and we divide by 1 over the marks, summation of the marks. So that's what it look like. That's what marks, that's the frequencies, and also you are going to take 1 over xi, it is a 1 over 11, 1 over 12, and also do like this. So when it comes for frequencies times 1, you are going to take here, you are going to take this frequency times this until you get this number. Do you understand? It's a simple. Take a pen and make a practical. So thank you very much. In the next session we shall continue by looking at the geometric mean, where you will understand many things. So remember, subscribe for this Arithmetic TV. My God bless you.